السلام عليكم ورحمة الله. بسم الله. نبدأ إعادة شرح Formation Evaluation. نحاول نغطيه بصورة أوضح عشان الشرح اللي كان سريع الفترة اللي فاتت، فإن شاء الله الناس تقدر إنه يكون الشرح أوضح إن شاء الله. For the outlines, we'll give an introduction. We'll go through major terms and operation in oil industry, mud logging, wireline logging, measurement while drilling and logging while drilling, log interpretation, calculation of hydrocarbon volume in reservoir, and assessment. You know how it's done. So as a beginning, you know that oil industry is classified in three sectors: upstream, midstream, and downstream. And in each sector, there is a special operation that takes place. So in upstream, it's mainly the exploration and production. Midstream is the transportation and storage, and the downstream is the distribution and marketing of the hydrocarbon. The E&P life cycle, or exploration and production cycle, we have talked about it many times, and we have explained the steps from the beginning, before even the exploration process take place. What are the main tasks that usually done in advance? So, for example, here we have to acquire rights, and we said that it depends on the country rules and regulations. In some countries, the government owns those rights, and in some other countries it's belong to the locals, so you have to make the contract with the locals. In some countries you make the contract with the government itself. You get your block to collect. We said that before we go for any further exploration, we have to look for the information that it's already exists. So we go through literature, books, and previous projects maybe have been done in the maps and database already exist related to this block or this field, because this can reduce a lot of cost and time. We will not spend much more time in that, and then we decide in our exploration program which type of exploration method we will do. So are we gonna do gravity, magnetic, remote sensing, seismic? All those decisions are being made in our exploration program before starting the exploration. So we will plan our exploration program before starting, and in the program, in the exploration phase, we do seismic or geophysics studies, and we drill also. And from the exploration wells, we mainly collect information about the subsurface, the formation, the succession of the formation, and we can get a clue about the chances of hydrocarbon accumulation beneath the surface. So if we got oil shows, gas shows from this exploration well, well, which is called the wildcat, the first exploration well which is drilled in the oil field. And after that, if we succeed in finding good oil shows and we end up to a conclusion that this oil field is promising, so after that we can go to appraisal phase. The appraisal phase is in which we collect more information. We trying to delineate the boundaries of our oil field and get subsurface maps and trying to estimate the reserve. We also estimate the reservoir properties in detail, porosity, permeability from logs. We can also acquire cores in the appraisal. Well, we also put in mind the environmental consideration, and more it has more drilling operation. We will drill more wells in the appraisal phase. The development in here, we already agreed that the hydrocarbon accumulation is commercial, and oil field it can be developed in order to go to production phase. And continuously through all those procedures and process, keep collecting informations and data in order to go to the next steps. And in production, we establish our pipelines and storage areas and all those things related to production. After the production takes place for a specific time and the oil field is no longer able to produce sufficient or commercial amount of hydrocarbon, the oil field is goes to abandonment, and in this phase we kill the wells and remove all the equipment, and we try more or less to bring the area to its previous shape. Like we remove any type of environmental contamination, any equipment, any tools, any whatever we can remove, we will remove it, and we kill the wells and cement it and isolate it from the surrounding. This is a bigger picture for the oil industry. So you will keep hearing the terms of integration and teamwork. None of those processes is actually accomplished by an individual person or individual group. There is always a teamwork and integration between different disciplines and different domains, and data exchange and knowledge sharing, information exchange. So we start with geology and geophysics, then based on the information in geology and geophysics, those data are given to drillers and in order to establish the drilling program. And this drilling program, we put in mind that in our concentration, the bottom hole assembly, and the type of tools that are used in the drill, the type of drilling fluid, the properties of this drilling fluid are actually related to the information that we get from geology and geophysics. The logging tools, what type of logging we need, testing. After the logging and drilling, we will test the well, and production, and getting some information related to the reservoir itself. Then we go to cementing, perforating, and production enhancement, completion tools, artificial lift. We will try to cover most of them, not in details, but to get an idea about what is happening actually in each phase. Now we will talk about the role of geologists in this whole story. We have the geologists have different roles in different stage. So in exploration phase, the geologist actually collect information from wireline logging and from the wireline logs, and in order to give information about the horizon and the extent of these horizons. And in petrophysics, here the geologist is trying to collect information about the physical and chemical properties of this rock in the subsurface of this reservoir rock. Are they porous? Are they permeable? And are they contain any fluids? Which type of fluids are there, and what are the properties of those fluids? After that, we go to production geologist, and production geologists will collect more or less the same information in previous, but additional information can be used in order to build a geological model, and this geological model can be used by reservoir engineers in order to understand the fluid flow and what are the causes, or what can happen after the production, what is the effects of the production in the reservoir, and how to produce from this specific reservoir. All this information which are continuously, or the data and the information which are continuously collected step by step are being used for decision making by different domains. Now we will come to the type of resources that we have. Conventional resources, and we have unconventional resources. And conventional conventional hydrocarbon resources are those resources which are located in reservoir rock, or rock which are having sufficient amount of porosity and permeability, and in which the production can take place naturally without any stimulation or any specific treatment. Unconventional reservoirs are those reservoirs which are characterized by low porosity and permeability, and they need specific treatment in order to be able to produce. So you need to do some kind of fracking, which is an enhancement recovery technique, in which you are trying to produce an artificial permeability, or artificial permeability in the reservoir. And those unconventional reservoirs, they don't have specific lithology, but in general, any lithology that is low in porosity and permeability and needs special treatment in order to produce is considered as an unconventional result. So it can be sand, it can be shell, or whatever. The only important thing is that it has no sufficient porosity and permeability to produce match. The second difference is that in conventional reservoirs we have the petroleum system, and we have already covered the petroleum system concept in the last year, and we said that it's contain both elements and processes, and petroleum system elements are the source rock, reservoir, and trap and seal, and we have the processes which are generation, migration, and accumulation of hydrocarbon. And we can go in details if we want to explain those processes in more details. We can say maturation, generation, expulsion, and migration, then accumulation. So those processes are absent, those elements are absent in the unconventional, because the same formation can act as a source, reservoir, and trap and seal for the hydrocarbon. Besides, there is no migration in unconventional. The hydrocarbon is kept in its original place. This is a conversion between conventional and unconventional reservoirs. Conventional reservoirs contain gas, can flow naturally and easy. In unconventional, low permeability make flow is not easy, so we need to create permeability by fracking the reservoir. Gas and oil migrate from source to source, which is the shale. Here in unconventional reservoirs, gas and oil does not migrate. In conventional reservoir rock are sand, fractured limestone, or fractured dolomite. In unconventional reservoirs, we have shale gas, shale oil, tight sand, coal bed methane, tar sand, or methane hydrates. Conventional reservoir easily produced by direct methods. So once you finish the drilling, you can easily produce by the reservoir pressure, or maybe artificial lifting, or in advanced stage you can go for IOR and EOR methods. But in unconventional reservoirs, we stimulate reservoirs by create fractures natural in the. So this is the conventional reservoirs. We have a source rock, we have a seal, we have a source rock, we have a reservoir, and we have a seal that prevent the hydrocarbon from further migrating. But in unconventional reservoirs, we actually dig through the source rock itself. So as we know, that source rock is low permeability. So this is the fracking. We create an artificial fracts in the formation in order to allow the hydrocarbon to flow through those rocks into the wellbore. So we get picture of the same conventional and unconventional reservoirs. As we see that the drilling through unconventional reservoir is always horizontal. We go for horizontal drilling, and the reason for that is to increase the surface area. So most of the source rock, the thickness is very low, and in order to capture more amount of hydrocarbon, we go for horizontal drilling through the source rock, and that will ensure a higher rate of hydrocarbons extraction from the source rock itself. Now we come to the type of unconventional reservoirs. So we have shale gas and shale oil, and those are oil and shale which can be extracted from shale. We have another concept which is gas shale and oil shale, and those actually very fine grain lithology, which is shale that contain both gas and oil. So there is a difference between shale gas and shale oil, and gas shale and oil shale. So in this case we are talking about the gas and oil which exist in the shale or in very fine grain reservoir, low permeability reservoir. We have tight gas sand, and those are sand which are characterized, saturated with gas, and characterized by a very low permeability. Coal bed methane is the methane gas which is combined with the coal, and it's formed during the process of coal formation. So, as we know, coal is formed by the decomposition of organic material, and this decomposition process create methane gas. This methane gas is trapped within the coal, and which can be extracted later through drilling in the coal pits. Tar sand is a type of a sand which is a mixture of the sand, water, and a very thick hydrocarbon material which is bitumen, and it's called tar sand, and it's very hard to extract since it's very thick in its form. And the methane hydrates is a type of methane. It takes a shape of crystals like shape, white crystal, and more or less it's look like snow. It's normally exist in very cold areas. Now we come to drilling and planning. We said that we have different type of wells, and before drilling any well we have to make a plan, and this plan, as we mentioned earlier, is produced, or it's arranged based on the information that collect or extract or interpret by geologists in the exploration phase. For an exploration and or appraisal, those different type of wells have different purposes. For exploration appraisal well, we actually need to confirm that there is a hydrocarbon within the reservoir, and in appraisal we said that we drill more wells in order to delineate the extent of this reservoir or this oil field or this rock bearing or oil bearing or reservoir rock. And the production wells here is to optimize production from oil and manage reservoir techniques. So the well is designed in order to get as much as possible of hydrocarbon from the reservoir. And here in this we will come to the concept of the completion of this reservoir. So the completion plan of the well is also designed. So if we are producing from one reservoir or we are producing from different reservoirs in different levels through one well, the completion is different. So, and if we want to isolate one reservoir from another reservoir within the production, we don't want to mix the oil produced from those different intervals with each other. So all this can be controlled in the completion of the production well. The injection wells those are the wells which are used in order to enhance the oil recovery in the oil field. And as we mentioned before, that after the well is drilled in the early stage of the oil production, the reservoir can produce naturally by the formation pressure, or if it's contain gas, it can produce by the gas within the reservoir, which is called gas cap drive, or water formation water drive, by the pressure of the water in the formation. After a while the pressure drop, and here it comes the need for artificial lift or pumps that can assist in the production of hydrocarbon from the formation. And in the last stage we will reach a point that even the pumps cannot produce enough amount of hydrocarbon, where in this case we will observe that the amount of water that is produced is more than the hydrocarbon, and this is called the water cut. As the water cut increase, we will reach a point that we need to do something to increase the amount of hydrocarbon and reduce the amount of water that is produced from the reservoir. And here comes the role of enhanced oil recovery and improve oil recovery this can be done by those injection wells, in which we inject fluid or gas in one well and in those injection wells and produce in another well, in order to push those hydrocarbon located in the reservoir to be extracted or to be directed to a specific well for production. Not to forget to mention that recently there is another technique for this enhanced oil recovery. It's called organic oil recovery, and this technique depends on bacteria and microorganism that is present in the formation in order to increase production. And in this technique they actually inject nutrients, and which is food for this bacteria in order to increase its number, amount, and activities, and that this bacteria will at the same time will help in the cracking the hydrocarbons which are trapped, small accumulations of hydrocarbon which are trapped and not produced, and enable the production of this hydrocarbon. Something else in the planning of this hydrocarbon, it's very important to plan those wells, because normally in each oil field you can have a huge number of wells, and drilling a new well in such an oil field can be a very critical and difficult task. So planning for the drilling in such an environment, in order to prevent the collision of one borehole to another, so you don't go through another borehole while you are drilling a new well in that oil field, and also trying to avoid faults in the area, and certain formation can be more easy or more difficult to drill in that oil field. So all those consideration has to be put in mind before the drilling start. After the well path is identified, the geoscientist and engineer will now exchange the information, or give each more or less the geoscientists will give them information about the formation, pressure, the fracture gradient, the wellbore stability, the porosity, permeability, lithology, faults, and clay content of the formation. And this information are critical for the drilling engineer in order to design the casing, the completion, how the this well can be completed, what type of drill bits, what type of bottom hole assembly that can be used, which type of drilling fluid can be selected. And this is actually a very important thing in various aspects. First thing, it will help you to avoid accidents that can happen by using wrong equipment during drilling. So if you have for example, a very tough formation and you use a wrong type of drilling bit, then that will cost more money. You will use more bits to drill, and beside it, and at the same time, it can reduce the cost. For example, if you have if we take the same example, the previous example, if you have a very loose formation, there is no need to use a very hard drill bit, which will definitely more expensive. So this will help you to choose the best tool that perform the task in the minimum amount and the minimum cost. So reducing the cost and increasing the efficiency of the operation as a whole. Now the routine drilling operation, we have the drilling, we have the casing. We talk about the casing, the type of the casing, and the cementing. We have already explained that the casing is being cemented. We talk also about fishing operation, when it's done, how it's done, the directional drilling. We also talk a lot about direction drilling. We will go through direction drilling in coming slide. Wireline logging, we also will come to talk about it in coming slides. Formation testing, coring, we have to talk about it previously, and maintaining and repair. Formation testing is engineering work in which you are testing the formation for production, before production, and you actually in this test you try to collect certain type of information about the formation itself, like the formation pressure and formation behavior during production, and those kind of information related to the formation. Maintenance and repair, and the borehole after it has been drilled, it will not just keep producing forever, so it will need repair and maintenance every once in a while. And because casing is made of metals, and metal can suffer from certain alteration, and those chemicals which are going through the borehole and can alter those metal casing, and for example corrosion can take place, and for continuous maintenance and observation and repair for those for the borehole after it has been put in production is very important and critical. We have some different type of wells. We have vertical wells, we have deviated wells, and we have horizontal wells. And we talked before that every type of well, why we drill horizontal, why we drill vertical, and when. So for example, we can go for horizontal drilling as we described earlier in the shale gas and shale oil, or in unconventional reservoir, in order to increase the interval from which we can produce, because those formation are, most of the time they are very thin formation. So in order to increase the interval from which production takes place, we can go for horizontal drilling. Deviated wells, in some areas we cannot actually put the drill rig directly above our target, so we have to move the well for further distance from the target, and in this case we can go for deviated or directional drilling in order to reach this target without disturbing whatever is exists above the target. So our borehole, our drill rig can be in this place. For example, in this target we have this lake, and we cannot put our rig in this lake, so we moved the rig in the land and we drill horizontally toward our target. Those are the main components of the drill rig. There is a lot of parts here, but we have the drawwork, which is move the top drive up and down through the borehole. We have the BOP, the blowout preventers, which is located on the top of the borehole to secure the wellhead and prevent any blowouts. We have the rotary table here. We have this is the rig. We have the top drive, the swivel, the pipe, which is carry the mud from the mud tank to the borehole. This is another demonstration for drill rig. We have the bit drill collars. This is the oil. We have the mud injecting hose. We have swivel. We have the travel block, which is moved up and down. We have the mud pump, which is pumping the mud from the mud pit to the swivel through this hose, and this goes to the borehole. We have a vibrating mud screen, in which we collect the drilling fluids from the borehole and separate drilling fluid from the cutting samples, because this drilling fluid is actually circulated once again to the mud pit and then mud pump and goes in continuous circle through the wellbore. We have in this place, we have the rotary table, and we have the Kelly, and we have the Kelly bushing. Kelly bushing is a part of the drill string, which is connected to the drill strings. The Kelly bushing is secure the Kelly in the rotary table, and this rotary table is transferring the rotary movement through the drill string. This Kelly bushing is very important for the petrophysicist and because in some cases the total depth of the borehole is most of the time is calculated from the Kelly. It can be calculated from the Kelly. The information is found in the log sheet, in the log header. You will find that the total depth is the reference for the total depth is calculated from which reference. So it can be the Kelly bushing. So this is to know where exactly the Kelly bushing is in reference to the borehole. So it is in the drill rig in this place exactly. This is the top drive, how it's look like, and those are the part. The top drive is transmit rotation to the drill string, provide access to the drilling fluid into the drill string through this pipe. The mud is coming through this pipe and drill and pushed through the drill string and support the weight on the string, so also control the weight on the string. This is a better view for the Kelly, and this is the Kelly bushing, and this is the rotary table. Now we come to the drill string component. The function of the drill strings. The drill string is to transmit the rotation from the surface to the bit, and transmit and support the axial load, transmit and support transitional load, put a require weight on bit on the drilling, guide and control the well of the trajectory, and allow circulation of the drill. And when we talk about drill string, is actually loose pipes, which is those pipes which exist from the rotary table down through the well bore, and the whole drill string is actually rotated, so the whole pipe or the whole set of pipes is actually rotating. And as we know that in order to make the drill operation more functional, you have to put some weight on the drill bit, and this weight, part of this weight is coming from the drill string itself, which is calculated by weight on bit, WOB. It should be well known and controlled. It should not be less than the needed amount or not more than the needed amount. If it's more, it will cause a damage for the drill string, bending and breaking. If it's less, it will reduce the drill efficiency of the drill bit, and allow circulation of the drill fluid. As we said, the drill fluid is actually moving inside the drill string and goes out through the drill bit and then move upward through the annulus between the drill string and the borehole. As I guess I showed you before in that video, you saw how the drilling fluid is actually moving through the borehole. Now the main components of the drill string are the Kelly or the top drive, and we explain what are the Kelly bushing, and what are the functional of each of them. Is to transmit the rotation from the top drive to the drill string, and the Kelly bushing is to protect the Kelly itself and connect it to the rotary table. The drill pipe, which is this one, also to put weight on the drill bit to allow the circulation of drill fluid through the drill string itself, and also I guess that's it. And the heavyweight drill pipe. The heavyweight drill pipe is a specific type of drill pipe which is heavier in weight. And the reason for that is to put more weight on it and to add more strength to the drill string itself. Drill collars, those are the drill collars, and they are connected within the drill string itself. We have the bottom hole assembly and drill bit. The bottom hole assembly, we have the stabilizer. The stabilizer is used for in directional drilling operation. It can help in direction, controlling the direction of the drill of the borehole. The reamers are to clean the borehole from the edge of the borehole. The crossover subs, those are type of connecting equipment in order to connect different tools with each others. And jarring device, those are equipment that can have ability to create sudden shock or sudden vertical movement within the drill string to prevent the stuck or to release the drill string in the case of stuck. This is a natural diamond bit. This is an overview for the type of diamond bit. This is the sidetrack bit, and this is the type of the bit that's using sidetracking. And sidetracking is can use in multi wellbores. If we have different hydrocarbon accumulation or small separated hydrocarbon accumulation, so we can produce from those multi hydrocarbon accumulation through one wellbore by sidetracking. And also to relieve in case of blowouts and leakage, hydrocarbon leakage from the borehole, so you can use it either to kill the borehole or to produce the hydrocarbon through this well and block this interval of the borehole. This is an example of drill pipes. You can see those are a result of maybe wrong choose of the drill pipe or wrong parameters within the drilling operation. Now you come to the type of rigs. We have various type of rigs. We have onshore, we have offshore. We talk about the onshore. Now we have the offshore rigs. We have drill ships, and we have the semi-submersible, submersible platforms. We have jack-up rigs. We have barge. Each and every type of offshore rig, it depends. As we can see in this, is more or less depends on the depth of the seawater. So as we go to the deeper water, we go with drill ship. The platform more or less go for shallow marine, because it has to be set on the sea floor. Semi-submersible, more or less till 10,000 meters. Those are till 12,000 meters depth, and those are to 9,000 meter depths, and those are to 6,000 meter depths. These are example of the platforms. This is semi-submersible. I guess I will stop here in mud logging, and I will continue in the next lecture.